So we have 4 talks, as he mentioned. So we will start with Kunal Das. He is also, he will introduce himself. So I'll give it to Kunal now. Thank you.
Hello, am I audible? Guys, good morning. Don't share the link to your families, mostly to your friends and colleagues for the conference. And yeah, I'll talk about that later. But today, the talk that I'm going to give is very simple. So I work at a company called CastAI, and I do a couple of things. So more or less, like I handle the Asia Pacific region at CastAI, and I do a couple of meetup like this in Bangalore, Mumbai, Kolkata, from where I belong mostly. Apart from that, the today's talk basically, let it come, okay? So today's talk is basically what I'll do is, so when you think about AI per se, we have to deploy it somewhere. It's not like you can't use OpenAI infrastructure or hit the API. That's for personal use case. We all know it's fine. But when you go into enterprise, you have to think about how we can train our own model, how we can train our own data. Or in some cases, we have to think about fallback situation if OpenAI goes down. Like the 3 months ago, Cloudflare situation is happening, right? So all those things considering in mind, today's talk I have catered. And why I am talking about like deploying AI models into Kubernetes. So, recent survey came and they were talking like presently at 60% workload that is running on enterprises, not in startup, enterprises. So enterprises, what does it mean? Like more than like 5,000, 10,000, more than that employees, right? So they run AI workloads into Kubernetes. Now, why Kubernetes? It has its own feature. It can scale really well, and it can handle the burst of spikes when someone hits the URL, and all those things are already baked into Kubernetes infrastructure. And now it is expected, the survey says that it is expected to grow to 90%. So it is really, you guys don't have to, like, if I'm a ML engineer or AI engineer, I don't have to really dig deep into Kubernetes, but I have to know how it works, basic functionality. So when the time comes, the AI is moving into Kubernetes, I'm prepared, I know how it performs. So that's what I'm going to talk about mostly. So Kubernetes by default, it's not easy. But many DevOps guys, you will see, they will say, okay, I have learned enough of it. I know how the pod works, how the scaling happens and all. Because there's a learning curve, like when we learn something, after learning a little bit, it feels like, okay, I know everything. Then it hits. Then the curve goes down. And after you spend 5-6 years, still you feel like, oh man, I'm not ready. So that's it. But these are like some CNCF tools. So CNCF is an organization that manages all the Kubernetes AI. So there is a organization you guys as a ML engineer should follow. It's called Agentic AI Foundation. They recently that got formed, and some projects are MCP, Goose. These are all projects that is undertaken by Agent AI Foundation. So this is currently CNCA Foundation projects are there. So while Agents AI Foundation have only 3 projects, CNCF that is built on top of Kubernetes, which is the largest project of CNCF, has this many projects altogether. And these are somewhere in nature or all, enhancing the capability of Kubernetes. Now, if you think, okay, this is too many things to learn about, this is not it. It has a second page also. So to handle this mashup or whatever the zoo, you either need a crazy skill. So you know how to handle terminal, you know everything, you know how to navigate through docs, or use automation. Now, when I talk about same thing in automation, so same talk, like almost same talk I gave at Hyderabad last week, and same talk I given in multiple locations, multiple countries. The question that comes like, if I do automation, it will kill my job, right? Why I need automation? I am the one who should handle the infrastructure of my company. But that's not it. So that's what I'm going to talking about. So automation is the key skill. When I'm talking about deploying AI infrastructure into Kubernetes, couple of things I need to keep in mind. First of all, basic question, which cloud I should choose, whether I should go cloud or I should go open source route. That's the biggest hurdle. Then there are a lot of question comes. If you start creating the playbook, it will be 1,000 rows. What VM I should use, what graphics processing unit I should use, how many scale I should use, how much should I pay, should I go spot, should I go on demand, or should I just ditch everything and go serverless? So these are some questions that comes when you think about deploying your own AI infrastructure into cloud premises. So managing all these things manually is the way that has happened so far. But if you use automation, you can focus on something else, that is your AI inference, AI research, rather than thinking about the backend infrastructure. So that's why if you think about the development cycle, right, Vercel and Netlify is nothing. You can build your own Vercel or Netlify. It will not take much time. But what it does, it simplifies the backend process for you, so the developer can focus on development and can just deploy it, rather than thinking about versioning, rather than thinking about how we can build our own app, all those things. Okay, so when I talk about Kubernetes, the thing that comes to everyone's mind, Kubernetes is basically very, by nature, is very highly available and scalable. So it's efficient by default. It should be, right? So this is a poll for you guys. I'm not sure whether it will work or not. Leave it. I think it is not working. It should come a poll, but no need to scan. So this is the survey result of last year. So last year we did survey across 200 organizations, and the average CPU utilization that they are doing. So they have procured the VMs from AWS, Azure, or GCPs, and the average CPU they are utilizing is just 10%. Memory is 23%, and we all know RAM is comparatively cheaper. So I'm not thinking about that. But what the 10% means, I'm paying suppose $11 per CPU, and I'm only using 10% of it, right? And think about it, it's just for CPU. And if you think about GPU, which is like almost 10-15 times costlier than CPU, if you go by this route, it just doesn't make sense. You're paying a lot and not using. So last year also we did the survey, it was 23%. And since a lot of AI workload is coming into Kubernetes, and you know that rapid infrastructure development is happening, and rapid development in AI inferencing and AI training is happening, and the infrastructure side, it is getting a little bit neglected. That's why it is had been reduced from 23% to 10% this year. So if I have to deploy something into Kubernetes, containerize it and deploy, what are the things that I have to take care? So first, all the VM or node where my AI workload will run must have the CUDA drivers per se. That's fine, okay? So when you run something on your system, you should have like CUDA drivers installed, right? That's given. And then something called NVIDIA Container Toolkit. So what is this? Container Toolkit is basically a way your container can act on the GPU that has inbuilt in your system. So suppose my system has a A100 GPU, okay? And I deploy a Docker file, but the Docker file is what? It's an isolated system. It can't directly call your GPU. It can access the CPU and memory. It can't access the GPU. For that, you have to install the Container Toolkit. Secondly, all the nodes that are there, you have to have something called taint and tolerance or levels. So what that does, so you deploy AI model, suppose Llama 2, okay, and that you deploy into Kubernetes. It will just go into the CPU node, which is not desirable. It should go into the machines which have GPU enabled, right? So for that, all the GPU node, you have to mark, okay, this has GPU, this has GPU, this has only CPU. And in the GPU also you have to mark, okay, this has only A4, T4, or this has A100. So if I'm deploying a higher complex workflow, it should go to A100. So all those marking you have to take care. Lastly, all those node that you are installing, all the softwares, all those drivers, it should have all something called a daemon set. So daemon set by nature, it installs all the thing into your node. But if you think this is all very simple, okay, I can write a script to install all this. So personal experience, last 6-7 months back, I was doing same project. And on top of that, you have to install something called PyTorch, a very simple PyTorch application. I was deploying a like CV application. Now you'll be surprised if I do latest version of every software, it will just crash. Stable latest version, if I install, it will crash. Why is that? So for some container toolkit version, some PyTorch does not work. On top of that, you add some CUDA drivers. So CUDA drivers, suppose 10.13.6 does not work with PyTorch 7.0.4. So you have to manually, these three variables are there. You have to manually figure out which works for what. Now for some time, like developers or AI, inference guy, they update the PyTorch version. These two need to be updated very cautiously, otherwise it will fail. It's a very complex scenario. Once you go deep, you are deploying something, and then suppose you are using external packages like Marks2Farmer or Detectron 2, it becomes very complex thing. You have to like play around with all the versions and all. Now, this is a real graph from a food delivery company in India. So this is what they're, before optimization they are using. So yellow graph indicates the amount they're actually using as a CPU, and the blue graph indicates the provision CPU. So in Kubernetes, first you suppose I am using 2-core CPU, you request 2-core, it provisions 2-core, and then suddenly you reduce it to 1-core, again it reduces, but the gap keeps remaining for some time. So this is what it is, and the gap, the more the gap is, the more you are paying and not using it. Got it? So simply just I use a AI optimization. What it does, it just checks every time. It predicts how much it should use rather than what's the proactive behavior. It reactively acts on it. So that's how, we're just optimizing. So you're not paying a lot more in the second scenario. So that's about like VM and node. Secondly, like workload. So it's very simple. I have containerized my AI application. I'm deploying it into Kubernetes. There are a couple of ways to scale it. So this is a container. Suppose it's what it does. It's a chatbot, okay? A very chatbot. It just takes a text input and gives a text output. There are two ways to scale it. I have one replica. I can create another replica. I can create another replica. So one can handle 5 users. Another replica will handle 5 more. Another will handle 5 more. That's called horizontal scaling. Secondly, once you deploy a pod, it can handle like 2 GB. It has like 2 GB of RAM. About one GPU attached to it that can handle same 5 users. So what you do, you increase the size of it rather than create another replica, increase the size of it. So now instead of 5, it can handle 7. But this process is a little bit complex. In industry, most of them, they replicate things, much easier to handle, and every pod will have same configuration. There are a couple of other ways also. So rather than based on the load, you can do based on queue, based on user behavior. So like Hotstar, what it does when IPL streaming happens, right? Not related to GPU, but just giving an example. So what they do, very nice talk you guys can hear at AWS reInvent 2022. So when they see like 1 lakh users are streaming the game, rather than that, they don't do a gradual scaling like 1 lakh 1, 1 lakh 2. So if 1 lakh users came, they increase 10,000 more. So 1 lakh 10,000, then 1 lakh 20,000. So when it reaches to 10 lakh, they increase 1 lakh at every, rather than gradual, it calls something like scale-based scaling. So they put a scale, and the scale distance increases, the number of users continuously gets attached to it. So all those things are a little bit complex. These are two mostly, used. Now, just to simplify, suppose I have all these pods and each are running its own application, and some are replicas. If you see pod C running here and pod C running here, so same thing, I just replicated it to 2 instances. Now, by simple logic, if I move this to second node, I'm not paying for node 2, right? And as high as if you're using H100, that costs like $11 in AWS, you're saving that cost per hour. Now, all these pods are running. Some pods, the application in it might not be using the defined memory that has that pod has. So suppose this pod D has 2 GB and 200 millicores of CPU, it might not use that. So I can reduce it, right? So that's what if I do it, so I can actually patch everything into node 1, node 0, and I can kill this node 2. So very simple explanation. By doing all these things, I'm just saving almost 60%, 66% of cost. And I'm not about cost, but I'm optimizing it. So I can use these two for other purposes. So that's it, right? There are last point that I want to discuss. Something are that, so when I'm moving one replica to another, I'm not actually moving it. I'm killing it and creating a new one, right? So it's not as easy as to move one from, you guys know, right? Suppose you are running some application in one VM. It's not easy to take it and move it. So basically you are killing it and starting a new one. But some application, for instance, when you are paying something, suppose you are like Razorpay, you're paying money to a client like Zomato or something. And while you are making the payment, the backend thinks like, okay, this thing need to be moved to other node. And if you just kill it and create another instance in another node, it will not make sense. The, it has happened to everyone, right? I have made the payment, it got deducted, but it hasn't reached to merchant. Has happened like 1 of 1,000 times. So these are called stateful workloads. So that has some state. Stateful workloads can't be migrated from one place to another. If you migrate it, what you are doing, you are essentially restarting it. For some application, restart does not make sense and it's so sensitive that you can't do it. So on this scenario, what we do is called container live migration. So by definition, live migration means moving one pod in the same cluster from one node to another without disrupting the workflow. That's it. It has some, how does it work? I'll just explain. But before I do that, just one line. It's very, there are some caveat to it. What caveat? You guys will agree with it. I can't just move from like suppose US to Europe. It does not work like that. It has to be in the same data center. But why? So suppose you are same example, you are making the payment and in between the machine moves from one data center into same data center, another VM. Okay, that works. But if you're moving from here to Europe, the connection will break. The TCP connection I'm talking about, it will break. So how does it work? Same thing, a node is there. I initiate an event that I have to migrate it from node A to node B, and the migration start. Once the migration completed, it again tells the control that migration is done, and that's it. It's as simple as that. Now, why do I need this? Again, same thing. Some pods are very sensitive that can't be migrated. Secondly, something is called in cloud provider called spot instance. So what is spot instance? So when you're using AWS or Azure or GCP, or every cloud has that, they have some surprise like excess VMs lying around that they want to give it to give you at a higher discount. Higher discount means sorry for that. So they generally give it at like 90% discount mostly. Now, why they do give it? They have the excess lying around, no one is using it. So they have procured the GPUs, they procured the CPUs, they have the VM lying around data center running. No one is using it, so they gave it to users at 90%. But why we are not using everything at spot instance since it's 90% cheaper? The moment someone purchases a VM or purchases a, they will evict that without telling you. Definitely they will tell you, but they will tell you, okay, within 2 minutes, I'm just taking this away. So the moment someone comes and asks for the VM, they will take it away from you. That's why it is 90% cheaper, but it is very sensitive in nature. So these are the some use cases why we run like use live migration. So it works mostly right now on AWS, but it's coming on other cloud provider. So I'll just quickly show a demo of it. Okay. So if you guys can scan the QR, like 2-3 guys, not like, okay. Can you guys see it? So after scanning, what you guys have to do, I'll just show. So click on connect to server. This is the server, okay? I'll just explain the demo, what I am doing actually. So what I've deployed the Minecraft game server into my infrastructure. And as you can see, the game is running. So I'll go back to my, so okay. 3 players are online. And here also, if I just go to the game is running here also, okay? Now, this is a sensitive workload. Why is it? So the server that it is running, the game is running fine, okay? Now, if I migrate it and if I just kill it and create another one, this player will get disconnected. Game will run for sure, like with 1 or 2 second interruption, game will start again. But the player who are connected, they will get disconnected, right? That's the most important thing. So these are 3 VM or 3 nodes that is there. So I'll just click. Basically, it's calling the backend API. And if you see, all the players are still connected, like 3 players are online who are still playing the game. If I go back here, still it is running fine. But again, if I come to my demo and if I start migration, so here if you see, the migration is happening. It is going from one VM to another and the game does not crash. That's the beauty of it. It's very complex in nature. If you see, there are 2 different systems. This software is running, the server or process, what is running. This has some internal IP. It's connecting to a load balancer. That's why you are able to connect. So from you to the server, from the server to the core, or every computation is happening, player movement, everything happening. I'm moving that from one VM into another, so I can just do multiple times. And without all the player getting disconnected, 6 players are still paying. Okay, so that's how it is. So yeah, that's a short demo I wanted to show. So right now it's available in AWS only, and GCP also, we are talking with GCP to release it soon on their marketplace, and AKS also is in plan. Yeah, see, they are connected. So 5 players are still connected. So they're playing now. Even if I go here, I can keep on playing. And it's not a single player. So see, this is another player, someone joined. And I'm migrating. It just works. So for now, it works on AKS. Like I have deployed this thing into AWS. What I have just shown you, it's a AWS nodes, and other places is coming around. So yeah, that's the demo I just showcased you guys. And yeah, EUS East one, famous one it got. So yeah, ping me anything if you have any question about this or anything at all. I'm very much active on LinkedIn. And yeah, that's it. I think thanks. Any Q&A? Like we have time for Q&A, right? Anyone wants to ask a question?
Is it coming in OCI also?
OCI?
Yeah.
No. So OCI, we are partner actually. So we do a couple of other things in OCI, but this live migration function does not work in OCI. Other things that I've showcased, right? The bin packing and everything, all those things works. So live migration is basically, it's very crucial thing and a very problematic thing to handle.
Actually, you switch the VM, including all the load balances, all the infrastructure.
Yeah. So that's how we are able to reduce the cost and manage the automation.
Backend, do you run any Terraform code or something?
So the whole infrastructure is built into Terraform. So you can do Terraform, Crossplane, Pulumi, whatever you have. Okay, whatever you are using, it's feel free to use. But all this movement and all, it happens via controller and something called CRIU, checkpoint restore in user space. So suppose you are running a Python application in one VM. So that is running and it has completed to 50%. And then we migrate that to another node. It starts from 51% rather than 50%. So your same Python file that you ran, a command, you will see all the history, all the command in the same VM.
We have so many live customers. So we, how will migrate it from one node to another without any disruption? That is the only. That's
what I just showcase.
Provider for that, Terraform provider, which you're telling.
Yeah, we have Terraform provider, but this particular thing, you have to like log in with the API, and then some controller will be installed on your own cluster, not our cluster, like in your EKS cluster. The controller is necessary because if the migration fails for sure, it has to revert back to the old one without a downtime. Correct. It has failed, to be honest. I will not lie. Out of 1,000 times, one time it might fail. A new node might not be ready. And there are some constraints also. Not only it has to be the same region, the both source and destination, it has to be like same CPU in architecture also. You can't move from Intel to AMD or something like ARM64. Okay, that does not work like that. You guys understand that, right? That's a SIP and processor architecture. It has to be the same architecture family and same data center. And if that's there, you are sorted.
No, we are in 26 regions. Like
sorry,
we are in more than 20 regions.
20
regions.
Regions. Yeah.
So region level migration, it won't happen at once.
It's not possible. To be honest, it's never. I don't think in future also it will be possible, because the TCP connection will break. So if you see the moment you are migrating, right, definitely there is some downtime, but TCP accepts less than 100 millisecond downtime. If I migrate from US to Europe, my downtime would be more than 100 millisecond. I have migrated it, not gonna lie, but the downtime is more than 100 milliseconds. So the connection that is there, it will break. So you note how TCP works. It sends a packet, acknowledgement received, right? So you send a packet before the acknowledgement received, and before the next packet sending, you have to migrate it. It's that crucial. So before the next packet, if I can't migrate, it will just break.
Okay. Thank you.
Yeah. Any more questions, guys? No, I feel we're good. Thank you.
Well, I hope that was a very productive talk and a very enlightening and good start for the morning. We have our next speaker, Manoj Tiwari. He'll be representing IBM. And again, he has a very interesting talk to talk about. I won't be spoiling it just yet by sharing the name. So I'll let him do the honors of introducing himself and talking a bit about his talk. So, Manoj Tiwari, please, a huge round of applause.
Hello, everyone. Hope I'm audible. Yeah. So, good morning, everyone, and thank you for taking this time out and coming here and giving me an opportunity to speak and to talk to you about AI, not as something that you have been looking at and listening to all throughout the internet. You guys must be hearing a lot of buzzwords around AI and how to build agents these days. And the most important point that I want to bring to this table today is about cognition engine itself, because I see that entire AI domain or all the YouTube that is covering right now is just talking about take this framework, take this agent, do this engineering, do prompt engineering, do context engineering. This is RAG, this is MCP, this is tool. You just assemble all those things, and you are good to go. You are able to build agents, and that works, right? But that's not the truth. We have all heard the news that 95% of the AI applications that are being built is failing. And why is that? The reason, so hopefully by the end of this talk, you would be able to understand why, and so that you can build a production gate system going forward. And and this is what the talk is all about. I will, though he announced that that my title as LLM as a cognitive engine, I'm starting with something called as RAG to reasoning. Why? Because we'll see. All right. So as I was talking about this terms that has been is being thrown around all over the internet, right? I'm sure pretty much everybody of you are listening to this. My question to all of you is, can you tell me what are different types of learning that you have heard? I'll give you one starting one, and then I hope somebody can answer me the rest. One is supervised learning. What are the others? 2, 3, 4. Summer? Transfer learning, contrastive learning, zero shot learning, few shot learning, right? Now, after having answers, since you know all of that, what do we build with this learning? Think about it. In all the learning, what do you build? You build models, which is one learning where you build something else. Anyone? Anyone? Reinforcement learning. You build agents directly there, don't you? Now, why is that people have forgotten that how do we build agents? I'll tell you why. Because most of the internet I'm saying, not talking about only YouTube, most of the internet are just giving you pieces of this building block. And they are not connecting this dot for anyone. And everybody, the entire industry is following this. And that's the challenge why everybody is failing. Because nobody's understanding this connection. So what I want to argue today is LLM plus plugins is not equal to agent. I want to argue this today. Hopefully by this end of the video, I'll repeat this again and again so that I can change the mindset of the people of hopefully in the future entire world also maybe. Let's see. So this is what I am proposing, and this is not new, by the way. This has been here since 1980, since the paper that was actually written by Burton, who actually got the Turing Prize this year and Nobel Prize for its reinforcement learning thing, right? So how do we actually build agents? What are agents actually supposed to mean, right? Any person. So think of any human also, right? What do? They perceive their environment. How do they perceive their environment? With their senses. Like you have 5 senses, right? So that is how you perceive the senses. These senses can be in any form. For example, you can read, write, speak, smell, touch, think also, right? We'll connect these dots to LLM agents in a moment. But I just want to give a idea how you can have an analogy, because the topic is LLM as a cognitive engine, right? Once you have that, you contextualize that, okay, for this purpose, I don't need this information. For that purpose, I do need this information. For this purpose, I might need some information, something like that. You contextualize it. Now, based on these information, you then reason about it, whether you need to do something or not, right? And then once you decide, you do take an action. Once you take an action, either it fails, either it succeeds, or whatever, you keep it in your learning so that in the future you don't repeat the same mistake and you try to improve yourself, right? Isn't that how we live, right? That's the cognitive loop. And this is what agents are also trained about. If you think about reinforcement learning, if you go and remember how reinforcement learning works, you will understand this is what we do, right? And why are people not able to connect this dot? Is again, internet to be blamed, right? Because they're just giving you dots and they're expecting the people will connect it. Hopefully this talk will connect the dots for you. Okay, so I'll come to, since I've spoken perceive and contextualize, I'll take, so I'll give you an example with RAG here, right? What do we do? For example, if you're building a chatbot that can answer you questions related to your documentation, very specific, grounded to the documentation of your company or your client's documentation or whatever, right? What do? You need to bring the LLM to that context. So you get that raw data, you just chunk it, and then semantically assign it or store it in a vector DB so that you can later retrieve it. But this is not the only way to retrieve information, right? There are others. We will talk about that as well, right? And then when somebody asks a question, hopefully you pray that it gets that perfect chunks from the data, brings it to the context of the LLM and gives you the answer. That is what the hope is. And that is not how it should be built, right? Because you need to have a metric for that. Unless you do that, how would you know? It might work for 1 page, 2 page, 3 page, 10 page, 100 page, but when the thing scales, it will fail. And that's one of the reasons, right? Okay, we'll move to the next one. And this is what I was telling you about. How many of you would have heard about this? Only two things up in the sky, right? Short-term memory, which is the context window. Semantic memory, which is vector DB. How many of you heard about the episodic memory and procedure memory? How many? Okay. So where would you use episodic memory in your use case? Sir? Yeah. Observability. Observability comes in the evaluation phase. Okay. So think about, so as I was saying, LLM is a cognitive engine. Think humanly. If you can think humanly, then you can program it, right? Episodic memory is like something like you're going somewhere, right? And then you do something, you achieve that thing or not, that's fine. That's one episode for your life, right? Then another thing, you do something else, you try again. So those different episodes of things, you can keep it in your memory, right? And that is what you need. You might need in your next program also. And procedure memory are like you would need, for example, you are trying to automate some workflows, right? You might be doing, and this workflow might have different permutation and combinations to be accomplished. You can store those things. And it not necessarily, there are two ways to store anything, right? Currently, at the given point, there is two ways. Either you can store it in a raw form, and LLM and any AI has given us a way to store it semantically, right? Procedural memories, you can store it just as it is, because what happens if there is a query and it is a long horizon question, and if you know this is the path that I need to follow, you can just give that path. You don't need to have that LLM to do that thing again for you. That's caching. You would have about CRAG also, right? This is just that. We are just rebuilding or rediscovering the same stuff that biology has established into AI. That is what we are doing. And that's nothing new. And people are throwing names at it. Okay. Now we have established perception. Let's talk about reasoning, and why I don't have slide for reasoning and decision is because LLM does that for us, right? LLM does that for us, but we have to intuit it to do that reasoning and decision making. And how do we do that? Anyone? It's prompting, of course, right? Prompting. We write that prompt so that LLM actually does that reasoning for us, right? And it takes decision based on whatever you are trying to achieve. And then when it has reasons about it, it calls the tools. And those becomes your motor functions. Now, tools can be in two levels. There is input tools and output tools, right? What about the input tools? For example, if you have a query, fetch me your data of Google stock, right? Then the LLM will reason about it, and it will call a tool that will fetch the data. And that data then comes into context. That is an input tool. There is no distinction as of now, but think about it. You have to build this mentality to build a correct agent here, right? And that's input tool. And the output tool is like, okay, once you have the data, and suppose you have written, give me an entire report of it, right? And it creates a report. Now, creating a report, you might have created an agent that writes a CSV file or something like that, right? That's an output tool, right? All of these things. And that's the tools give you a power to act on your environment, nothing else. Now, let me close this. And where I was about to come about the observability or logging part, right? Because think about it. Anything you are building, if you don't have a metric to show that whether it is working or not, how are you going to tell whether it's working or not, right? And most of the difficult thing in the entire industry that I'm seeing is people don't have a metric. You don't even start a business without having defined a KPIs. And how are you starting with building agents? I see people just calling the LLM API, writing prompt, then writing whatever question you need to ask, and saying, okay, oh, I'm getting an output. Oh, that's great. It's working. Well, it works. But what happens when you start scaling? When people said, okay, here's another document, try to get the answer from here, and then it fails. And you're like, okay, what to do now? You are panicking, and you just go to Google, ChatGPT, Claude, and you're like, okay, this is a document. Here's what I want to achieve. Give me prompts. Right? You don't even write prompts on yourself. You get the prompts from somewhere else, paste it here, and just pray that it works. Right? That is what is currently going on in industry. Anyone else facing this? Everybody's, and this is the wrong way. This is the wrong way. Okay. So my point is, how do we do this? Whatever you are doing, collect at least 5 data points, right? Collect just 5. I don't think so 5 would be enough, but at least have 5 data points for the thing that you're doing. Once you have 5 data points, that would be your 5 training data point, 5 evaluation point, 5 training points. Once you have that, now what happens is suppose you built an agent, right? That is supposed to call 2 tools, right? Let's simplify it, 1 tool, right? Now, once the question is asked and you are expecting that the LLM should have called this tool. Now you test it. How many times did it call? If you have 5 data points, and if it is calling 4 times, that means you are 80% right. Right? You have a metric to evaluate, correct? Now, and then you have another 5 data points where you don't, where you expect that LLM should directly answer the question. Then you have 5 of them data points, and if it's telling 5 out of 5, then you have 100%. That means, okay, this is at least working. You can show and prove it to your clients or whoever you're responsible to, right? You have a metric to show. That's what I'm saying. And having said that, you would have heard about something called as DSPy, or recently 2 weeks ago, Microsoft launched Agent Lightning something, right? What are they doing? They are closing this entire loop, this cognitive loop, where, think about it, when you are building an agent, React system, whatever, the only thing that you change is the prompt, right? Apart from programming, right? And if you have to anyways write prompt by going to ChatGPT and getting the prompt and pasting it here, why not do it in a systematic way? And that is what Lightning does, okay? Or DSPy. DSPy has been doing it for 2000. If I remember, 2023 it was released. That was the paper, right? But yeah, you can follow that. And I see nobody talking and nobody connecting these thoughts to everyone. But yeah, that's the idea. Hopefully you can get it. And yeah, coming up with metrics and datas, this is an ingenious part because there are 2 types of outputs of LLM. Anybody can tell me what are the 2 types of output that an LLM gives? Anybody? And how can you evaluate? Because the evaluation is a very big thing. Again, I can go on for hours on that topic, right? There's 2 types of outputs. Yeah, anyone? I saw hands raised. No? Yeah. Those are, you can govern the structured and unstructured, right? But yeah, more or less something in the same line, right? There's open-ended and closed-ended, right? Open-ended, I'll give you first closed-ended so that open-ended makes sense, right? For example, if you're trying to generate output from an LLM, a SQL, right? And that's closed. Why I'm saying closed? Because you can evaluate that. How you can evaluate it? Because when a query did it say LLM? I'm sorry. I meant SQL. If you're trying to generate an SQL using an LLM, right? Those kind of things are close-ended. Why? Because you can evaluate that, right? Why? How you can evaluate? Because you can write that. Because when you run that SQL query, you will get an output, which then you can evaluate if that which then you can evaluate is that correct answer or not, right? Those even structured output, you can evaluate that. For example, you're generating JSON. You know what is the correct JSON that you wanted, right? But what are the closed? Now this is a closed generation. Open generation. What is open? And for this evaluation, it is easy. You can do one on some mathematical metric you can use, right? But for open-ended, for example, you have a huge document and you're trying to summarize, right? Now, summary can depend on somebody else's preferences. You might like some other summary. I might like some other summary. You can write some other summary, right? How will you evaluate that? You have to come with an ingenious technique to improve, to measure that. Can anyone give me one example? I'll give you one example. Okay, I just came up with this right now, right? So, for example, you have you're trying to do this summary thing, and you want to evaluate it. And I would like, okay, if I have this document, I embed this document. This is my summary. I embed this summary, and then I do a semantic similarity scoring. And if the semantic similarity scoring is about 70%, if it is 0.7, summary is acceptable to me. Okay. Something like that. You have to come up with these things. You see, why Claude? Those are also agent. ChatGPT, those are also agent. Why those are successful, and where you are seeing news where people are failing with 95% of the people are failing? Why? Because they have cracked this loop, right? And nobody else is teaching about this. Nowhere, right? And that's the thing. I hope this talk changes mindset of people here, right? But yeah, I'm trying to do something else on my. I'll come at the end for that. Okay, cool. So let me talk through to you about some more terms that are being thrown about this, about MCP, right? What is MCP? Like MCP, if I put it in the most simplest term, it's just a API wrapper on top of tools. Just that, as simple as that. Wherever you can use tool, you can use MCP. That's it. Simple. And we discussed tools, right? Input tools, output tools. Example. Now, coming back to training, right? Remember how we train agents in reinforcement learning or any type of learning, right? Not agents, but models also. It's not that you just write one thing and you get the output. You have to continuously evaluate it, improve it every single time. Same thing. How many of us have actually done this while building agents? I haven't seen nowhere. Nowhere happening. People just write it and just pray that it works. It doesn't work that way. You have to continuously improve. And when I mean improving the agent, it's mostly correctly prompting the agent and building the correct context out of it, right? And programming is always, of course, always there. So once you have figured that out, you can obviously improve that. Now, what is this about? This complexity mandates the loop. Why? Because think about it. LLM can do a few multi-hop type questions, right? If you give, I need to do this, I need to do this, then I need to do it. It can do a limited amount of it. But if you want to do, if your course is a long horizon course, you have multiple hops, you would need multiple agents where the multi-agent system comes into being, right? That is where it is. And you have to think about it that I need to divide this portion as this agent. And this is where different agentic architecture comes into being. This is where you need to learn about it. That is why this is also important, right? There are 6 types of more important agentic systems or architecture, I would say right now, that everybody should know about it. At least those are the basics. Once you know that, you can probably go ahead and create more. I have not put in the slide. I'm sorry about that. But if you want to know, we can talk about that later as well. Cool. Now that we have talked about why we need multi-agent systems, now this is what? This is just another simple way of putting it is an API layer on top of agents. That's it. It is as simple as that. And this is one kind of protocols, right? That as we have different kinds of communication protocols, we have different kinds of agenting protocols also that keep coming. It was introduced by Google, I think, and there are many other people, they are also giving their own protocols. MCP has also been challenged, but I think those are getting thrown away, right? But yeah, as people expect whatever one protocol it works, then it works, right? That is it. There is nothing fancy about it that people make up. It's not fancy. Cool. Okay. So as I have been debating and querying about that, when you're building an agent or system using LLM, don't just think about plugging in those features that just you see on the YouTube. Today is a trend. For example, just now before I came here, I saw this. Yesterday only, I think, the 5.3 and for ChatGPT 3, ChatGPT and I'm saying ChatGPT, GPT 5.3 and Claude 4.6 was released. And I saw again the same, every YouTuber is like, we are broken that trend. We are higher here. Now this thing is gone, job is gone. I'm like, dude, come on. I don't know. I hate that, but what to do? That is how clickbait works, right? I also want videos. I'll have to do that. But yeah, hopefully we're in the real RAM here. And next time when you build agent, you think about building a person's mentality. Cool. So I would conclude this by saying we are no longer just adding features. We are assembling cognitive architecture. That was the whole goal of my talk. Hopefully, once you have seen the loop, you can't unsee it. Thank you all. And thank you for listening.
Yes, any questions?
Hi.
Hello.
So when we are developing an agent, the choice of LLM provider matters.
To be honest, yes. And to be real, no. I'll tell you why. Because you build something using an agent, right? And if you have built, you have experiences already. Because I don't even need to answer. Because if you're training, you're building something, your manager or somebody will, hey, start with 3.5 or whatever open source model you have, you just start with it. And then later on, when we get access to better models, we just replace it. Did you ever felt anything range? It did not, right? It did not. And let's be honest. Why? Because there are different ways to actually evaluate. That is a different use case altogether. And that is why I was saying the evaluation part it comes, right? If it is working, you will just accept it. But if you're doing the evaluation, then you don't even have to ask this question. You will yourself answer it. Okay, this model is not working for me. Currently, it is working at the MVP stage. But what happens if I scale the data? What happens if you change the questions? What happens if somebody use different wording? What happens if somebody changes the language itself? Then you'll have to definitely change it, right? That's the answer to that question. Thank you.
One more question.
Yeah.
Like when we are building a production grade agent, is it best to use APIs of this enterprise applications like OpenAI, or should we like fine tune and quantize a model and deploy it in our own infrastructure and use it?
Okay. I'll quote this answer from Hugging Face themselves, right? I admire that company actually is OpenAI. Okay, we should change that name to them. But yeah, the answer to that question is you actually is it's not about using open source. Open source versus closed source answer comes not based on what you're doing. The answer comes based on how do you trust that models, right? If you don't want your data to go outside your company, then you come here. The question is not related to whether it's working or not. As I said, it will work both. But having said that, if you look at the benchmarks, if you look at any leaderboards and all, you'll see this closed source models are working better. And if I have to bet, if I tell you that, hey, there's this person who is from IIT, this person is from MIT, this person is from third tier college, you blindly will say, okay, I'll take this MIT guy, right? That's the same question you're asking me, right? You look at the benchmark, you're like, okay, this is working, let's do it. But that other guy, he can also do the work. It will also work. He might do better for you, right? For example, I don't know if you guys following or not, but recent trend is SLMs, small language models. Why? People are like, it is taking too much compute, too much energy. Elon Musk yesterday said we will send satellites and get energy from there, we train our data here. I'm like, what? Why? So think about it. It's crazy. The new money is going to be energy. Somebody Elon Musk claimed, right? So that's the answer.
From your, practically, how are you when you have very short sprint cycles? How are you ensuring that you are doing development and also working on understanding the traceability, observability, and the parameters that you mentioned? How are you doing the trade-off?
Yeah, that is why this whole topic is about. It's not happening in the industry, sir. And that is what I am trying to change here. And why I'm trying to change is why, and how I'm doing it. Okay, it's slightly general. I'll maybe add this thing. So I am trying to create YouTube video while I'm working in the industry, like everybody of you, and I'm trying to change this narrative of how we actually build this agent. I'm not sure how far I will go. I'm not sure how convincing I sound. And to be honest, I'm doing this for the very first time. I'm very nervous, but hopefully this is going good. But yeah, as to answer your question, sir, this is not happening in the industry. But what happens when during the client phase you do MVP and all, it's very fast phase. You have to do it in like 3 months, 2 months, something like that, right? Then you don't have to do it. But when it goes into the phase one thing, then you have your project management meetings where you can actually decide that this is the data you need to go, this is the stakeholders, this is in scope, this is out of scope, this is the data that we not. All of this you can have this, and then you can start with this, right? That is how you should do. That is how we should be doing, I feel like. And for internal projects that are where I am the sole owner, I do it that way. And personal projects that I do it that way because that's the right way to do it.
Right. We have got two more quick questions.
Yeah.
First.
Yeah. So at my work, what I've seen is like, a lot of times all these foundation models, they tend to be like non-deterministic in nature, right? Like they don't have one specific, pipeline to follow. So like, how do you like, at a very broader level, how do you take care of, like making it more deterministic and in nature?
LLMs by nature are non-deterministic. To make it more deterministic, you would have heard about this guy also suggested, and you would have seen that this is also a later structured data. Yeah. Constraints are there. So you would have heard about guardrails also, right? Guardrails are also applied on the two sides, the input side and the output side, like input guardrails, output guardrails. That also depends on what you're trying to do and what you're trying to constrain. Those are there. But your question was about constraining the LLM deterministic, right? So for that, what people are doing, and it is recently this trend has picked up, right? There was this recent paper also. I forgot the name of that paper, but what they claimed is LLMs are natively good at getting structured output. So what and think about it, our entire network internet has been built on this structure. And what is that structure? JSON, right? So people are like focusing on training their LLM such that it can produce JSON. Once you have JSON, you can serialize it and put it in any other functions and API calls. That is what is going on right now. That is one way. And there are others, obviously, right? But you can definitely never, at least till now, you can never make LLM deterministic. So that's this nature of the thing.
Yeah, next question. I wanted to know, like, till now, how the software development used to happen with all the programming languages, how it is going to change with the advent of LLM. Like you said, like evaluations and many things are in place, but there is no structure to it. Like, do you have any framework which we should be following to make sure, and how much deviation in terms of timeline, like and deterministic way also, like when we use programming language we know what would be the desired output, but here we have to put more effort in testing, doing that loop wise, running those loops again and again to make sure we reach that accuracy that it is close to the programming language. So how it is going to shape in coming days?
Yeah. Actually, there is a structure beneath it all, and that I'm trying to actually make YouTube series on that. My friends are also here, so they know my ideas. So I'm trying to actually there is a very beautiful mathematical structure to it, very beautiful, and I just want people to know I just don't know how to do it because I'm a very bad teacher, by the way. So I don't know. I'm trying to, and how it will evolve, I'll tell you. You follow a YouTube channel called as the Neural Maze. Just type it, the Neural Maze. You'll find structure. You want more structure? You learn this book called as LLM Engineering by Paul Lutzen. You watch this. There's structure to those. And it will, and as I'm saying, right, everything has a reason why it is happening. There is nothing unstructured. It's just the way that people are just randomly making videos. Nobody's connecting the dot. For example, everybody would have heard about CloudBot, then it became Modbot, then it became OpenClaw. And then I saw videos everywhere like, okay, how to use this, how to deploy this, how to make this from scratch somebody made. I was like, what? Why? I mean, why? So so once you get this fundas right now, you will see that framework automatically appearing. Okay, I'm not sure where to point out to, but you follow these two things, it will be clear for you. Hopefully, right? You'll have to definitely connect the dots again. But yeah.
All right.
Or else you can wait for my YouTube videos if I can upload someday. Then yeah.
We have more couple of questions, but I've asked them politely to just wait until the lunch hour and connect with you in the networking session to just ask for more questions. I hope that's okay. All right. Thank you so much, Manoj. And yeah, more number of questions is a clear sign of high adoption of, the content. And besides the content, I must say that these were some of the best looking slides that I've seen over the years. Thank you so much. Right.
I want to give a disclaimer of that, right? Thankfully you pointed out, I was talking to about it to he's my sir and mentor, Rajesh sir. So so I made this using LLM. By the way, the most value is being driven by using the products and tools and services. So don't be afraid of using. I used Notebook LLM. You saw that, right? People can't even imagine it is doing that. I was like, wow. When I first saw. So don't be afraid. And if anybody says, okay, this is destroying our mindset, yes, it is. Yes. But don't use it for normal conversation, right? I mean, use it to your benefit. That's the thing. So don't feel afraid or don't feel shy that, okay, I've used it. I could have just cut it down and posted it, but I brought it like this. The reason was that I wanted to say this, but my sir told me you don't need to. But since you brought it, I wanted to tell. So feel free to use. So that's the first layer, using the tools and services that you're seeing. That's where the most values are being driven. The second layer is where you actually using the LLMs, multimodal LLMs, VLA, VLMs, whatever, and building things out of it. These are the two things. Machine learning research have become really niche, right? If you want to get that's another thing, it's a lot of things there, but yeah, that's it. Thank you.
Well, don't be surprised if people walk up to you and ask for the exact specific prompt to come up with those slides because they were nice. And yeah, thank you so much, Manoj. Thank you so much for your time. Gagandeep, over to you.
Thank you. Thank you for having me.
Once again, thank you, Manoj. That was a very productive and insightful session. Now, to take things further, I am excited to invite our next speaker, Prashant from Cloudera, who would be sharing on learning at the edge. So let's welcome him with a huge round of applause. Over to you, Prashant.
Hello. So your name? Avinandan, you had a question that LLMs being more deterministic than a non-deterministic, right? Sorry? Yeah, correct. So they are more non-deterministic than the deterministic. If you look at the inherent implementation logic, that top K, top P, temperature, those are the critical factor that influence your non-determinism. So if you bring it down to a zero value, it will be mundane and it will be deterministic. So to deal with that, what you can do is you have to be working on your semantics of response, if those are aligning to each other. So that should solve your problem related to the non-determinism in LLM.
Hi everyone. Good morning. So so I will be speaking on these topics today: continual learning and federated learning. So you already heard from Manoj, there were different types of learnings are there. So just a second. Yeah, so the topic of this talk will be major focus on the forgetting problem. So we already aware learning and machine learning and these types of things. So this will be mainly on the forgetting problem, and then also we'll see that how we can do or how machine can learn without sharing the data if we have private data. So yeah. So, quick introduction. My name is Prashant Bajpayee. Currently, I work in Cloudera data engineering team. So, yeah, this is the agenda which I am planning to cover. So, first, I will discuss why learning over time is difficult, then what is forgetting problem, and how continual learning helps in it. And then we'll discuss about the federated learning, and finally, we'll talk a little bit about this federated unlearning. So this is I'll start with this question: can AI get memory loss? So I'll ask a quick question. So do you remember all of your subjects or all of your let's say friends who were in maybe your college or in school? So do you remember all the subjects? I don't remember. So this is the human tendency that we forget some of the things when we start learning the new things. And this is, I think this is one saying also. I heard in my childhood that you have to forget the older things if you want to learn new things. Okay, so why this question is relevant here? If you see, so in today's AI world, the data is keeps on changing. New data is appeared every day, and so okay, I will tell this with using one example. So let's say we have one model here. It is already trained for two diseases, pneumonia and tuberculosis, and then after some time, let's say COVID-19 came. So what will happen now? So we want the same model to also understand the COVID-19 data. And at the same time, we want to make sure that it should not forget the knowledge about the pneumonia or let's say tuberculosis. It should not forget the older knowledge. Okay, so what is forgetting problem? So just to show and experience it, I did a small experiment. So in this experiment, I use this MNIST dataset. It is a very popular dataset in machine learning. And to mimic the exact scenario, what I did, I split this dataset in 5 tasks. Task 1 containing all the images of digits 1 and 2. Task 2 contains all the images of digit 3 and 4 and so on. And then I created one model and I did the learning of these tasks in sequential order to mimic the exact same scenario. And this is the result. So model significantly forgets the older tasks. You can see in the graph here also. So the dark bars, these are showing the original learning accuracy. And then once I learned the same model continuously for all the 5 tasks, then again I re-evaluated that how the model is performing on the older tasks. And you can see there is the drop in the accuracy. So this phenomena is called catastrophic forgetting, when the model forgets the older knowledge while learning new one. So this is called catastrophic forgetting. So now the question is how we can fix it, or not fixing, how we can control it. So that's where the continual learning comes in picture. So what continual learning, it is a mechanism to so learning new tasks without forgetting the older knowledge. So it is also known as lifelong learning or incremental learning. So we have some approaches. The current approaches we have replay revision based, we have regularization based, and there is one more knowledge distillation. So I will discuss these approaches one by one, just a very high level so that you can get some idea. So, okay, first approach is replay based. So this is, here we can see the power of revision. So if you remember in our childhood or even college days, again, the same example. So, I mean, we used to revise, I mean, while learning the new things, we used to revise our older concepts or older formulas. And why we used to do this? So that we should also remember those things. And the same thing, the same concept we apply with machines also. So again, okay, so how we do this? So for all the older tasks, we keep some of the examples from those tasks who actually represent, who better represent that type of task. And then while learning the new new knowledge or while learning on the new tasks, we mix, I mean, we also provide those older tasks to the model so that it can revise. So again, I did the same experiment, similar experiment to see, okay, whether the revision of older tasks will improve the learning, I mean, will reduce the forgetting problem. So this was the older result, which we just saw related to this catastrophic forgetting. And then this is the result. So I observed that this replay technique reduces the catastrophic forgetting. And this is the graph you can see here. So here you can see, especially in the task number 3, 4, 5, you can see a significant improvement. So here the green bars represents the evaluation of or the accuracy of older tasks after learning all these tasks in sequence. So if you have any questions, please ask. Okay. So the first one was the power of revision or replay based. There is one more technique we have, the regularization based. So what was the problem with the power of revision or with the replay based technique? The problem was that we have to save some of the examples from the older tasks, and that cannot be good because of the privacy. If those examples or if those training examples are sensitive, so it might be the privacy breach. So there we have this regularization based. So at high level, we can think of regularization is to kind of regulate. Okay, so in machine learning models, how learning happens exactly. So there is no database or memory as such. When you train any model, so the training adjusts some of the parameters. And then we basically measure the accuracy that, okay, whether those parameters are adjusted correctly or not, or acceptable or not. And then, so this this technique, it will regulate, it will control that which parameters you can change and how much you can change. So the concept here is we learn one, let's say task A, that is old task. And then while learning the new task B, we also tell model to not change those parameters which are important to the older tasks so that we can retain the knowledge of the older tasks. So here we use this Fisher information matrix. This is a mathematical thing. So using this matrix, we can get the sensitivity of those parameters. Okay. So there is one more technique. There was one more technique, knowledge distillation, that I have. I'm not covering because of due to interest of time. So the next question is: can AI learn without seeing your data? Okay. So now the next question is: can AI learn without seeing your data? So this is very interesting question, because how a model can learn if we don't if the model don't see the data. So I will tell you the context here. So the context here is related to data silos. Or if you see the simple real world scenario, so we have multiple hospitals, for example, and they have different data. But the problem here is that because this data is related to patients, these can be the patient records. So these cannot be shared across hospitals due to this privacy constraint here. So in this, in this type of scenario, we can apply the federated learning. I can tell you one more example that is related to, let's say the banks. So we have the fraud detecting mechanisms or fraud detecting models in bank. But see, if we want a good model, if we want a very good model, so we want a lot of data to be trained on. But even the banks cannot share the transactions between themselves. So with federated learning, we can address this data silos problem here. Yeah. So now the question is, okay, how can we train a shared model without moving patient data? And that's where this federated learning comes in picture. So what we do here in federated learning, it is a decentralized training method. So traditional machine learning or standard machine learning, what we do, we get all the data at one place, we get, and then we have one single model, and we train that model using all that data. But here in this, in the previous example, the point is that data is not at central place. Data itself is distributed or decentralized. So instead of having the training at a global model, let's say, we do the local training. We train, we also, so okay. I think, okay, so I'll explain how it works. So this federated learning concept itself is first introduced by Google researchers, and it was mainly used for the models on their keyboards. So if we know that even on our mobile phones, we have models which runs, for example, next word prediction when you type, and that works without even when you are offline. And that's the reason, because the model is running there itself. So it allows the machine learning models to learn from the data which is stored on the edge devices, let's say smartphones, or in the or organizations for like hospitals, without exchanging the raw private data. So here the concept is, instead of bringing the model, so instead of having a centralized data, the concept is that, okay, bring the model to the data. So so what we do, we have one global model. We okay, I think, yeah. So here, even if you see in this image, we have one server, that is the global server, and it maintains a copy of model. It shared that model with all the participating clients, and then all those clients train their local data on that model. And then what they do, they share the model updates. So here you can see, in machine learning model, what is the important thing? The weights. So instead of now sharing the private data, the participating clients will share the updates, the weight updates. So we are directly not sharing the data, and that's the concept here. Okay, so these are the steps we call. So we have one global server which maintains a global model. So first, it will in the first step, it selects selects the client, the number of clients which can participate in that communication round, and then it sends that global model to these clients, and then clients will train this model on their data. Then clients will send the updated weights to the global server, and then the global server will aggregate these weights and apply in this model. So through this way, we have a global model which has the intelligence or knowledge of all the data. But not directly. Even though this global model has not seen the private data directly. So again, I did one more experiment here, that how this global model behave in federated setup. So to mimic this, I have created one setup in which 10 clients are there, and then used the same MNIST database. And this time, to mimic this scenario, I split that data, and I provided the data, splitted data to all these participating clients. And then I run the training for the 20 communication rounds. So here you can see this is the accuracy versus rounds. So you can see the accuracy of the global model is increasing as we have increased the communication round. And the same way, the loss of the global model is decreasing. So yeah, so there are few challenges in federated learning. So I told that when there are so during the selection process, global server selects some of the clients, and then it waits for those clients to send the model updates. So let's say if some of those clients are not good enough, they have some network issues or some other things. So this is the first problem. If we have some clients which are slow, in that case, the global model has to wait. The global server has to wait to get all the updates from all the participating clients. So as an engineering strategy, we can say that, okay, let's train in the async mode. So we apply the async mode. So instead of waiting for all the clients, we put some constant that, okay, if let's say the participating clients are 100, and even if we get the updates from 60 clients, we will aggregate those updates. But here again, there is one more problem. Now the faster clients can dominate the global model. So if we have, let's say, because here these are the model updates. If we have some clients which are having specific data, let's say on some different data set, maybe chest or some other type of X-rays, and if those are faster clients, so our global model suddenly will have more intelligence about the knowledge or about the data of these faster clients. And there is one more thing, that is the client drift. So it generally happens when we have non-IID data, non-identical data, you can say. So that will cause the tug of war situation. So when we train the model with the data, so generally the weights gets updated, and if we have let's say one type of data, so during the training, some important weights will be there that will be updated. But let's say if we have multiple clients which may have different type of data, let's say in one example, let's say we have the dogs and cats images, and the second client also has dogs and cats images, but the format is different. Maybe those are the paintings of the dogs and cats. So you can see the features are not exactly same. So these type of things can cause the global model convergence. They can make the convergence worst, because it will take a lot of time to make all the clients in sync. Okay, so this is the last question of my talk today. Can we erase memory from AI? So before checking the AI, okay, so what we are doing with AI, we are trying to mimic the human brain, or not human brain, but human intelligence. So I will ask one simple question. If you remember any incident or anything, can you forget it? Can you try forgetting it? Not entirely correctly, but yeah. So okay, so this is one question. Even if you spend weeks or months, you cannot. And if you want to forget some special one, so that is even not that is even not possible. So okay, and why this question is relevant? So we use Gmail, for example, let's say, or any other platform, and if we want to deactivate or delete our account, okay, so we can delete the account, and the deletion is simple. We can delete the entry from the database. Google can delete your entry from the database. But what about the model they have already trained with your data? Even if we search today in ChatGPT or Gemini, so they are also applying training on your questions or prompts, whatever you are interacting with. So even if you deactivate your account, it is very hard. Why? Because in case of database, we can simply write one simple query, SQL delete query. But in case of model, you can see, especially in this federated setup here, you can see the global model. So global model itself, and okay, so this is the concept of right to be forgotten. So this is one important thing, which is I think the question, and maybe not having the good solution as of today in this AI world. So now coming to this federated learning part. So here, what are the challenges? So one challenge is that if you see the models, if you see the updates, so on the global model, the updates itself, those are aggregated updates. Those are aggregated updates, and even it is hard to identify. We cannot tell that, okay, which part of model, which weights are changed due to which clients. Even the same type of weights can be updated or changed due to the influence of multiple different clients. So the question is how we can do the federated unlearning today. So the simple answer is, okay, so any idea how we can unlearn from the machine learning?
Context, it's basically distraction.
Hmm?
In human context, it is basically distraction. Well, you're not forgetting it, but in time or in history, you are forgetting it.
Yeah, I mean, and correct. So when I try to distract, so that time, let's say if I want to forget something, and when I try to distract, so and then I think that, okay, why I am distracting? And at the very, at that moment only, I mean, I again used to remember that thing. I mean, it is, yeah, but so correct. But your point is correct that with time, or if you started learning new things, or if you add more experiment in your life, let's say, so some of your weights in your in your mind model will be will get faded or something. But it is not. I mean, you cannot completely vanish the memory. It can happen only when your model or brain is not working. Let's say.
I completely agree. We can't untrain, but in this case, does guardrails become more important because it can filter out data which you need to unlearn?
Correct. But this is for the future. How about the past? How about those data on which your model already got trained? How you will remove that intelligence from the model? Because you don't know those weights come from which intelligence. I mean, which
untrained, but we can restrict access. That's the same as untrained.
Restrict access from whom?
From the model, we can add guardrails so that such information which you don't need access to can't be accessed in the end. So is it the same as untrained?
From model training perspective, yes. But let's say if, for example, let's say consider these two neurons highlighted in yellow. Okay. And let's say if we have two user data, two clients are there, which has influence on these two neurons. Now I say that, okay, you want to remove, or one client is saying that I want my right to be forgotten. I want to be forgotten. So how you do this? You because you don't know. And if you change something in these two neurons, so you will impact the knowledge, the understanding, or the intelligence from the other client. Sorry.
When we send this data for training, do we maintain any metadata like these aggregates are generated from this user, which can be used to be forgotten? But I do not understand, like, if that data is gone, what will have an impact on the training? Like, that is where is the concern, right?
So this is good research problem. So ma'am, in which, I mean, are you working, or so which company you work? Okay. Yeah, I mean, okay. Why I ask this question? Because these kind of experiments we have to do to understand. This is one very good experiment that, okay, how we can do by saving the metadata. But you just think once, if let's say we have 100 clients and there are hundreds of communication rounds. So at each communication round, we are updating the model. So how much metadata you will save? And then how you will track that, okay, in which communication round the same client updates which parameters. And if your model itself is large, so how many parameters you will save? But yeah, I mean, this can be one approach for research. But yeah, a good point. Sorry, you were asking.
To restrict, it might sound silly, but how about if you restrict applications that use that particular data?
How if you?
If you restrict applications that use that data itself, so over a period of time it will be forgotten.
Yeah, I mean, so that's the question. If we have one client who want to be forgotten, so the DB deletion can happen instantly. But yeah, on the model side, it will not happen instant. I think this is your question, that if we restrict the data, so after some time, those weights or that model will forget, or this is the question. Yeah, so I mean, you have to wait. But the question is, in this case, have we actually implemented the right to be forgotten thing? I would say partially yes, partially no.
Basically, I think you retrain or do something for unlearning where you send the weights which are unlearned. So that is the two ways. One is brute force and other is unlearning. That's the two ways of doing
okay.
it.
So I think this is a very brute force or this is the basic thing, retraining. This is this is compute intensive. It will take lot of time. But if you actually want to remove the data from model, so it is equivalent to if we retrain the model without using that particular data. So this is the foolproof method which we have, or which we can say that this is foolproof method, through which we can unlearn the things. So
is only retraining the here. Sorry. So is only retraining the present solution that we have, or because the way the human mind remembers or forgets things is when you're remembering something, like let's say you're remembering the same thing a second day, and you're remembering the same thing the third day and the fourth and the fifth. On the day when you are remembering, you're not actually remembering the event itself, but you are remembering your past memory of the event. So like when you're remembering on day 5, you're actually remembering on whatever happened on day 4. Like what was your memory of the event on day 4? So instead of having to retrain the entire model, what if there was some sort of a protocol that could just make sure that it is slowly but surely remembering just what it last remembered?
Okay. So I will correct one thing here. When I said retraining, it means completely forgotten. It is if you want to apply this right to be forgotten thing in true sense, then currently this is the option. But yes, to answer your point, we have some techniques through which we can apply machine unlearning to reduce the influence of that particular data. It will not, so that will not completely remove the effect of your data, but you can reduce the influence. So
we are talking about completely eradicating the data rather than forgetting it.
Yeah, I mean, yes. So you see, you cannot completely forget. Right. This is, at least today, I don't think, as per my knowledge, we don't have any method.
Any foolproof method.
Any foolproof method. Any foolproof method is retraining. That is actually, I think, will not be feasible.
Yes.
So that's why I said there is no perfect solution today. If you research on this topic, you will find some methods through which you can reduce the influence. Okay. So what we covered today, we covered forgetting problem, and then we discussed how we can learn without sharing the private data, and then we discussed some of the things related to machine unlearning. So I think that's it. From any questions?
Yeah, I have a question. So hello. Yeah. So instead of going for federated learning, what if I just anonymize the sensitive part of the data and still keep the rest of the data as is, in the sense that I'll keep all the features, but then I'll only remove the sensitive data, like the name, the address, phone number, etc., and then still train on the centralized manner.
Yeah. So see, definitely. I mean, it depends which features. Let's say if your training or if your requirement doesn't want or doesn't need those particular sensitive data, then definitely we should not use those sensitive data. And one important thing is, when I discussed or when I talked about this federated learning, so it is solving one main scenario here is that is of the data silos. So if you have any use case where you have the data silos and you cannot share the data is private. In that case, definitely the federated learning, as of now, the federated learning is the way to go. But yeah, I mean, to answer your question, so if whatever data is not needed for your use case, my suggestion would be do not use that data in training.
So my point was more about like only the specific part of the data which is like, for example, the healthcare example that you gave, right? So in that one, like I'll only hide the things which are directly related to the person. Okay, so let's say I have cancer, and then what should be done in the data set is that just remove my name and the phone number.
Okay,
and
I get it. Yeah.
Still continue to do the same.
So, okay, so you are saying instead of sharing all the private data of address or anything, you just share the.
Just remove the sensitive.
I mean, yeah, I mean, that we can do. So, here, okay, so that is one thing if you discuss about the banks or other things. But yeah, I mean, there are multiple ways as of now. We are all engineers, so we can devise a lot of things. So, these are, this is the topic related to mainly on the research side. I wanted to cover from that perspective. So yeah, and that's it. Thank you very much. Thank you all for attending. You can connect with me.
We are getting requests for a couple of more questions. Again, same request. If you can hold on until the lunch session, during the networking, you can just connect with him. And a fun fact, Prashant is the very first time speaker. The quality of the talk, the class of the talk was top notch. Thank you so much.
Yeah, thank you. I didn't know that this is a very good thing.
We have Rajesh from Cloudera. So please welcome him with a round of applause. So.
Hi guys, am I audible? Doesn't look like. Oh, thank you. So what's the topic today? What's the topic today? Sorry? Very good. And looks like none of you have egg in the morning. So that's not the topic. This is the topic. EEG. And today we are talking about hack to future with AI. And if we talk about that and without leveraging AI in the space of neuroscience, then we are not really hacking to the future. Right? All right. Thanks for acknowledging. Okay, here I am. I am Rajesh Kumar Mishra, Senior Engineering Manager at Cloudera. I have overall 20 years of experience, and from past 2 years, trying to train some of the models. I don't know if I have been successfully done it, but so that's about me. Today's agenda, we will talk about EEG. Have you heard about ECG? How many of you have gone through that? I think everyone, when you have annual health checkup, so every one of you would have gone through the ECG, right? Mine is bad. So, and similarly, we have a way to read heart. Similarly, we also have a way to read brain signals. So that's going to be the topic of today, and how it has been done. I'll give you the high level overview. I'll not flood you with a lot of technicality on a different aspect. I will stay on a high level because I want you to encourage to explore that area where a lot of research is happening all over the world, including in India as well. So that's where we will talk about the inspiration. How did I get the inspiration to get into it? My intent, BCI, brain computer interface, and then EEG. Then we talk about the multimodal AI, contrastive learning. That is one critical part here. And then CLIP as an extension or enhancement of the contrastive learning. EEG is another modality. Perception, game of brain. You all know how does our brain work, and we are identified by our perception as an individual. What you see and I see perceived differently in a different aspect, and what are the challenges in case of the EEG data reading. Okay, all of you know this person? From Mahabharata, that has always been very interesting to know how did the whole chessboard was played during the Mahabharata, and that would have never been possible without the ability to read someone's mind, be it your friend, be it your foe. So he has the capability. And why did I, although we consider him as a godly figure, but as long as he was on earth, he has to abide by the physical law of earth. But still he managed to do that. And if it turns out to be very far in the history, then let me cover you the recent phenomena. Einstein, you all might be knowing. He claimed that he could use only 5% of his brain. I don't know how much I have a max limit. How can I tell how much I have used? Anyone here who can claim that how much you have used? Knowing our true, unless you know the max value. So for example, I score 5 out of 100. What's my percentage? 5%, right? I don't know what score I am. What is the max score? So how can I tell that how much I have used? So I've been wondering. So one of such case recently, that is Einstein, who proved to have exercised a lot of his brain. And being on Earth, he has been able to see the far things, which is the universe, governing the universe. And it is amazing. If you have not spent some time to understand how his brain was working, I would strongly encourage go and read about Einstein. All right. Here's my intent. Me and Manoj and Suzanne are under the supervision of Dr. Vignesh. We are doing some research from IIT Jodhpur. And this is our area of research. So I would be sharing this is consider this an encouragement for you to, as a young generation, to look at what are the possible options. And if that is mentalist or the reading mind is possible, may not be at our level because we fail to pick up some of the features. If we talk in the context of dataset and AI ML, as our brain is not tuned, but whom are we tuning? Machines we are tuning. So they can read that, right? And step forward, as I started, if we drop the ball on neuroscience, then we are not going to the future, hacking to the future through the AI. And trust me, a lot of research is happening in this space, especially the BCI. You all know probably Elon Musk, and he's one of the company which is doing research on neuroscience. What's the name? Excellent. So here is the starting point, BCI, brain-computer interface. You would have, how many of you feel or seen that BCI in action? Just the excellent. True. Beyond that, I don't want to be plugged in anything. I'm fine. So that's the worst case if I have to be plugged in. But otherwise, it is solving. Yes, it was there in the Stephen Hawkins as well. But nowadays, precision have increased with the help of AI, and things are moving really in a faster space, which will, if it is used in the right direction, as I always say, there is no single coin where you do not have both the side, good and bad. So I always focus on the good part of it because that enables some of the folks who are physically impaired to enable them. And the recent Chinese research has shown people with paralysis, they've been able to communicate, the play game, but without moving their hand and leg. They were able to, and this all happened through the brain BCI side. So there are 3 categories. One is called invasive. So they will open the skull, put some of the electrodes inside your brain to pick up pure signal. Until I started doing research on it, I didn't know that I myself is a battery, which has a potential differences, and I can emit signals from the brain, heart, and even my neurons. So that's an invasive one that gives an accurate reading, but this is invasive. It has to be operated, open the brain, put the chip inside, and then that picks up the signals from the brain. And signals like if I am blinking my eyes, that's also a signal. If I'm thinking something, that's also a signal. If I'm sleeping and dreaming, that's also some sort of potential differences are happening, right? And another is a semi-invasive. In that case, they simply open the cortex, they do not go and put the electrodes, but they put some of the circuits, printed board circuits inside they do not go and penetrate the brain cells. They stay on the top side, but still it is a surgical process. It's not like a non-surgical process. They put it and then let the people to interact and do their job. There is another one that's called the non-invasive. We will see that more. There's a cap with the different electrodes. Electrodes number can vary from 16 to 256. As the number grows high, the number of signals that you get interpreted is really high and noisy in nature. Just put it into the context of AI. If you have ever gotten a chance to write your ML code or AI code, you have to pick up some of the meaningful features to extract some more information and process it effectively. So we'll talk about that also. This is how it looks like. Invasive process, you see there is a, I don't know if it is it visible? See this. This goes and sits in your brain. Pins goes and sits in your brain. This is just a cortex get opened and printed circuit boards lie down. And this is the EEG reader, which is non-invasive in nature. That slowly this is gaining popularity because adoption rate is high because there is no surgery process involved. This is the EEG, and it stands for electroencephalography. What does that mean? It is derived from the Greek word electro, related to the electrons. Encephalography. Encephalo is N, and cephalo. N says inside, cephalo is brain. So sorry, inside head. Encephalo is head, so which turns out to be the brain. Graphy is recording something as a reading. How it works? So, for example, if my phone rings now, if I'm moving my hand like this, some of the activity happens in the mind, and this whole signal system sits inside, very dense and condensed in the mind. And when they interact, they discharge some potential, and then that get read by the electrodes attached to the scalp, not the hair, but it has to be connected with the scalp. And why it is noisy? Which is very noisy?
The mind is very noisy. The mind creates a lot of unnecessary.
We need to do the meditation for that, right? All right. So yes, mind is noisy, and we should learn how to get control of it. And one of the criteria when we collect a data set that we wanted to make mind calm, then only we can read something. And that is the first step today. I'm talking about today, at present, whatever has happened. In future, probably with a computational capacity or a lot more data set, today there is a scarcity of data set. We cannot read a lot of things from the mind. So in future, probably somebody who does the research and on a variety of subject, probably sometime in future, we can see a better effective way to understand our mind. This is the different frequency at which recordings happens. So if you see on the right side, it's visible. These are the different gamma, beta, alpha, theta, and delta, different range of frequency that get captured. And if you see on the right side, it says heightened perception, learning, some activity is happening. And then your brain emits higher frequency signal. Similarly, when you sleep, let's go top and the bottom. When you sleep, see the readings are comparatively smooth, non-noisy, right? Not lot many activities are happening. Okay. Now, multimodality. How many of you understand what multimodality is? I'm sure most of you, if you have used ChatGPT or Gemini, you would know that, right? But it is another way to interact with LLM, artificial intelligence. But otherwise, we are all multimodal, isn't it? I can talk, I can listen, I can see, I can experience something, 5 senses. With the 5 senses, I'm capable to understand what is happening in and around me. So multimodality comes as one more modality that talks about how can we interpret data, which is available to us in certain context. All right. Contrastive learning. What does it come to your mind when you say the contrastive learning? What does flash into your mind? Stark differences. Okay. You know that after we are born, we always are into the same contrastive learning mode. Agree? Disagree? No? Okay, let me explain that. Probably that will I'm a father of 2 kids, and both are son. They don't like to come to me, but they prefer to come to their mother. So that's a contrastive learning. Father is thorny, mom is caring. All right. So that's a contrastive learning. As we grow, we come across lot many people, but we have only very few and specific people whom we prefer to stay together. We call them as friend. Others as an acquaintance. That's all always happening. So in the space of AI, if you want to innovate something, here is why suggestion is watch out yourself what new learnings you can add. Right? So putting it to the context at this time, what is happening worldwide? What is happening? What sort of learning is happening? Wars are happening. If you are up to date with the latest news, and this was can be categorized as a destructive learning. Somebody has learned how to destroy, and this destructive learning is happening, right? So we got to be careful. And Prashant mentioned we have to unlearn that. If you really want to survive in the AI space, we need to unlearn that. Otherwise, what will happen? AI will start picking up those traits which are most talked in the internet space. From where AI is learning? From where ChatGPT is learning? From? From internet. And what do you tend to get on internet? Positive news, positive things, or negative things? If you have to do the comparison, if you do the soft max on it, what is the probability of getting the higher value? 80% negative news, right? And what is the probability of that model going to learn on negative things than the positive things? Approximately proportional to the what has been fed into that through the internet. So my concern is that if I have to worry about future, then I have to see every day morning in myself in mirror what I'm transpiring, what trend I'm setting as an individual. Am I writing something which is positive or negative? So if answer is negative, then I have all the reason to be concerned about, because first you can change this within you. We cannot expect AI to do something great, right? To put it in the another perspective, a person who is born and brought up in jungle. Who was the animation character who was born and brought up in jungle? Mowgli, right? Mowgli versus village kid. Who was more wild? Mowgli. He learned that, but a villager boy learned from the village society and etiquettes. So that is what I'm concerned about. So now the coming back to the contrastive learning, this is the foundation of all the learnings, and multimodality comes into picture, and this is a part of self-supervised learning. Manoj or someone, I think Prashant talked about. Manoj asked you different type of learning. So there was supervised, unsupervised, reinforcement learning. There's something called self-supervised learning also. That means you gave it, it's trying to learn on its own. So contrastive learning comes from that category. There is a lot more advancement happening using the Ian LeCun, right? Ian LeCun. So iZepa, Zepa, and all, they are all going into that direction. They are more capable today, and their future prediction is when AI comes, it's like us instantly. We don't need to feed data set. Instantly, I should be able to act upon certain task. So contrastive learning, it is a very fascinating thing, and I'm surprised when I explore this paper, how did they come up with this very natural phenomena? But it ultimately drove me to understand they just kept monitoring themselves, human behavior, and you can come up with your own learning mechanism also. So there are 10 such mechanisms today, the different learnings. You can come 11th or 12th one by yourself if you closely monitor our behavior, our intelligence. So in this case, what happens? Anything which is similar, they come closer, and which is dissimilar, they go beyond the margin outside. So that applies in our case also, right? Some of the people we come across, they come closer to us, be friendly, and then those who are not within our frequency range, they automatically distant away. So how does this is you can correlate? You all have social media, right? Facebook, LinkedIn, whatnot. So you have a trend, you have a natural inclination whom to follow, whom not to follow. And how does it happen? Because you do the contrasting. Who is giving more value to you as an individual versus who is not giving you. So that's why you keep track of it. So this is what exactly happened in the space of embedding also. So we try to compare two objects. If those are similar in nature, we get them into the single space. That's called the proximity. Those are not relevant. We just push them away from the margin. CLIP model. It says contrastive language image pre-training. Heard about this? No. Okay. So contrastive learning, we looked at it. This happens on the image space. Now, what happens when you give some information and language and image, they come closer to each other? Say, for example, dog, an image of dog running with variety of image of dog, and then you wrote something about the dog running, dog eating, dog swimming, all those. So these all fall under the same space clustering. And if you look at the clustering, they all fall in the same space, and they go related to each other, right? This is how it looks like. So before training, you see all these entities are parting away. This is I'm talking about in a two-dimensional space. When you talk about CLIP, that works in a 512 dimension. So after the training, you see they have come closer, which are relevant. Here you have some text, and this red color text, they have come closer. After training, I'm suggesting. Similarly, with the blue color and green color, which before training they were scattered here and there, now they are semantically correlated to each other, right? Now, if I ask you, when we do this thing, can we have our brain signal also similarly behaving? If a dog is running, what's your name? Shashank. If a dog is running, if I see dog is running, you see the dog is running, same view, and Amit sees the same dog is running, will you be reacting same way? Absolutely not. And what is the difference? Okay, your previous encounter of the dog. Somebody has like Samriddhi has a pet at home. So dog has home. So she won't be afraid of, right? Our perception will change. So that is the total game. So, but keeping that, we pick up an object which is neutral enough, not animal or anything of that sort, but we keep the objects neutral enough. Most probably we'll all think in the same direction. Correct, arguably. I'm not telling everyone, because thoughts and perceptions define us individually. But most of the 80%, 50% cases, we'll all react in the same way. If you look at the sugar, what would be your mind? You are not diabetic. I'm also not diabetic. I have not tested though. If both of us are not diabetic, what would be our reaction? Sweet if you see?
Or if I see sweet.
Sweet. So you will feel like eating, right? So both of us same phenomena. Someone who is having a problem with the sugar, they will repel it. Correct. So similarly, this modality is about that. If we can, EEG as another modality, if we can capture in a controlled environment and try to understand brain in a better way, we can probably correlate all this. We can at least get a signal from the mind what an individual is thinking. May not be 100% right, may not be 80% right. Even if we reach by 50%, we are still in the game. Maybe future we'll at least pave the path for future someone to do further investigation and research on it. So answer is yes, it can in theory. Why in theory? Because in practicality, it all depends on what an individual is. If he's suffering from something, the sweet might repulse him. If it's not suffering and absolutely healthy, they will pounce on it and they will have it sweet, right? So that's
how this current neural network works and how the brain thinks. These are not, identical at the moment.
They are not identical. Absolutely, they are not identical. But we're inching closer to that identicality. So that is what the whole endeavor is happening. And that's just scary, as I told, because of the internet impact and all. Okay. So here is the scheme. If we have to add EEG data to read our mind and a human mind, that would be another modality. EEG signal would be the another modality, right? How can you do that? So if I go a few slides back, you see this one. Here, image and text are trying to have a diagonal relationship. So in the while training, we all club together of a statement of a dog and image of a dog should align. And that is, now you add an EEG into it, it's become a 3D figure. And in a cube, it will be diagonally aligned in the cube. So similarly, but that would take a lot of time and effort because you have to prepare a lot of data set, and then you have to have a control environment where whatever images are there in the clip, individual has to show that and capture the EEG data. There is another one without touching clip. It's like a software reusability. You have defined your base class, you have defined your classes, interfaces, library well, so you don't need to tease it. So here the same thing is happening. This is one of the proposed architecture, not by me, by another research.
I have a question related to the EEG signal modality. Does it vary from human to human? And
does.
if it does, so whatever data set you're preparing with respect to clip, right? Let's say you show the clip image and you run the text by him and he reads it, and then there's some signal produced, and then that's what you're consuming here.
Correct.
But then when you prepare this data set, this model will be more personalized to that person, right?
Yes, it will be.
Okay.
And as I told you, the reaction to an object when we see or perceive it are purely depend on an individual. How does he or she perceive that scenario?
And how is it different from another individual? Have you checked
It's
that?
again subjective, no? So for example, we're talking about the dog example. You have a pet at home. I don't have a pet at home. Another person has been bitten by a dog. So all three of us will have a different perception by looking at the dog itself. Right? The person who is bitten by the dog, it will recall what has happened to him. So now the dog and the biting and the thought that is coming is totally different what your perception is because you have a pet at home. In my case, I'm neutral. But I'm fed from the Facebook, Insta, and YouTube that dogs in the same lift can bite you. Right? I'm afraid. But you are not. We know how to deal with it. And others already traumatic. So they would have a different experience altogether. And the EEG signal will also reflect that.
Right. So tomorrow, if we want to get this, scaled up to all people, you would have to collect their EEG data.
Absolutely.
Along with their environment.
That is what the typical challenge with the EEG.
Right.
So every individual has a different perception to the object they perceive.
Got it.
And how do we harmonize it? In a control environment, we do not keep an object which can trigger some way. There is a possibility. I'll tell you that also. So for example, I'm in a meeting and I found another person in my team. He has a very good t-shirt of a particular color and that looks really great. And I'm planning to buy. I'm planning to buy a t-shirt and that is going to influence me, right? That's a perception again. Now the same color car we saw in a image while doing the training, what would trigger? This color t-shirt I have seen in somebody wearing it and that was looking great, I should buy that. Possible? So that's what my perception is, my experiences, my past defines me. What I'm looking for in future, what I saw, and what I've been subject to in a test. So in that case, there are challenges. Like there were challenges to travel to Mars and Moon. So I'm hopeful, I'm positive. Sometime down the line, we would have a better mechanism to understand, which is not today. But what has been happening in Neuralink and other folks are doing, they're really aggressive, and especially China. China has a lot more active work is going on. So I'm sure they would pave a path where every detail will come up in maybe matter of few years. I will not even foresee it as a decade. In few years, we will see the positive outcome coming.
I see. Thanks.
Okay. So in this case, what happens? We try to embedding space you all are aware of. In the embedding space, you get anybody near to that, even me in the 512 dimension, then I will be trying to resemble with somebody, even though I'm not totally responsible. It all depends on how the network has been designed, how I have written my loss function. So that defines this space. If I have to come closer to some entity, then I have to have some feature resembling to that guy, right? If I have designed bad, it will bring me, but I'm not nowhere related to that object at all. So this is what one such case. It's a baby step to that. A lot more networks are evolving, a lot more architectures are changing. So this is one such case which I thought I'll just bring to your notice. It will, because it is very intuitive. You have a clip model aligned to image and text. You have trained a person, a subject, with the subset of those images and text, and then you try to see what is the match. Having said that, there could be a stark differences how the individual would have perceived and claimed to be right or wrong. So far with me? All right. So this is one such case which we can reuse it and try to leverage it. Yes.
So I have a question. So you said about EEG having different perspectives to different external.
EEG not having a different perspective.
My
We
bad.
have a different
Right,
perspective. EEG reading reflect us differently.
Right.
Yeah.
So what if we were to consider something that goes in parallel along with EEG, something like fMRI's functional connectivity scores that goes along with it. So if we were to take that parallel correlation and use the same clip model to use the same concept of grouping by similarities, would that work?
That is what exactly has been talked about. If you see in this case, what we are trying to do is we want to bring, see here, EEG channel net encoder has been reflected there. That is responsible to give you an embedding of EEG content, feature learned from that embedding. And it try to align itself with the, say for example, car has been shown here, red color car you see here. And here we have fade in the car only because we don't want to have a color impact on that. So we wanted to normalize as much as possible so that we can get the neutral behavior from an subject. Okay. So that is what it's trying to do, and trying to get embedding of EEG closer to the car that a clip model has learned so far. Okay. Having said that, this is not very straightforward. In our research, we have not found a similarity. We have struggled a lot because underlying network is purely number and human. I'm too bad in the numbers. So I'm not sure how many of you are good and bad. So that's a typical problem we have. Running out of time.
We're getting good follow-up questions. So are you open to take them as they come, or
I'm okay to get as I'm come.
Please.
Okay. Okay. So we talked about the perception. So perception is what we get defined, and that's I call as a game of brain. So we all get defined by our perceptions, our past experiences, where we are cultured, nurtured. Okay, and this is our area of research.
So you are working on the research, right? So I am thinking of, before we have formed this perception, we can try it on like the non-invasive method on children. Like when we have formed that perception of, for the dog example you told, right? Before we have formed that fear, there will be some, like when the child see that particular animal, there will be some that signal will be changing, right?
Noise is coming. You're talking about having EEG on kids?
Non-invasive method.
Sorry? Correct. EEG is a non-invasive method. It can be, but kids are yet to learning. They are, which age group you are trying to cover? Below 5, they're still learning. Even some cases, even 10, 12 also. What can be controlled in an adult? We can at least tell them this is a calm environment. You just stay focused for a certain time. Say, for example, 1 second or 500 millisecond. It's called a stimuli. You are shown you have rapid fire. You are asked a question and you are supposed to spontaneously answer this. Something similar happens in this case. You are shown an image and then removed. So what comes immediately, that get tracked as part of the EEG. And that is the trick has been used in this case. Okay. Kids case, it will be quite weird. They see the red color car, they assume the lollipop.
Okay.
Okay. All right. So this is our team. Vignesh Mulidharan, he's from the IIT Jodhpur. He is my guru and Manoj and Sizon's guru. This is a team that we are building up. And I have been trying to learn AI from 2020. Unless self-discipline is one of the critical things. you get yourself enrolled somewhere so that be effective learning. Self-discipline is not my cup of tea, so I decided to learn from somewhere. So that's where sir been helpful. All right, floor is open. Thank you very much to listen me patiently and being an interactive crowd too.
One more question. So earlier you said that the EEG is going to get converted into an embedding. So this is a time series data, right? Like how
Time
exactly
series, yes.
Because images
There
and
is-
text you just feed it to the model and
Hello?
get the embedding.
Hello, echo हो रहा है.
I think it's okay.
Hello. Okay. So yes, it is what you saw right now is a time series data, but there are research and different aspects into it. Feature that's called the feature extraction, because you have assume you have a 128 channel set in your mind, and if you are doing some active work, then all neurons will fire all together. When they fire it, then you would get a different reading from all 28 channel. For example, as I'm talking to you, I'm blinking my eyes, I'm moving my hand, and at the same time I'm tapping my foot also. So these are all noise to what I'm talking to you, but not for you. It is not a noise because we are verbally communicating, but for EEG, that's all noise. So we have to be careful about it. So for example, there are also technique to remove, say for eye blinking, heartbeat, or any stomach pain that can get anything that is repeatedly happening, not stomach pain, that's a bad example. I'm sorry about that. But eye blink, heartbeat, or anything that is happening without our notice, that's also driven by brain. And this all related to your neuron get fired in your mind. So that's also get captured. So there are technique to remove such noise for eye blinking or heartbeat. You can remove it. So that then you can define your data set appropriately so that particular feature can be extracted from that time series data, or that's called a spatial also, because we have 128 or 16, 32, 64 channel or 256 channel EEG cap. So you need to learn how to remove such noises. It's challenging. It's not easy. It's challenging, but there are research happening, and we are trying to do a bit of it. I don't know how far I will be successful. It is 6 months actually. So, but no intent to stop it in next 6 months. Probably will pursue it. There are different factors come into play. Personal interest, bandwidth, time. So based on that, our intent is not to stop here. We'll continue the research until we get something meaningful. Sorry? There is, but that's a subject of research. So I have not talked about many things. That's called the downstream. I have just spoken about a generic path where my intent is to encourage you guys go and explore what best can be done. It is need not to be my team or by us. If anybody from India does it, I'll be feeling proud about it. You guys. Yes.
Like how frequently do EEG models needs to retrain due to signal drifts here?
Come again, I could barely hear you.
Like how frequently does EEG models needs to retrain itself due to some signal drifts?
Oh, okay. That purely depends on your data and your satisfaction level. Say, for example, you have a data which is precisely explaining what exactly you need. All the models are static in nature unless you have learned it from Prashant. That's called continual learning, but that's not intent here. In this case, at least in the brain, at present, what we are doing. But if a good amount of learning, today success has been achieved in the classification, but not the object detection and all through the EEG data. So if in the down the line, that is the need that, for example, Rajesh want to be monitored 24/7 to the EEG cap, then yes, that's something called continual learning, or that Prashant talked about it. That need to be factored into it so that it keep on learning itself based on the data provided. Otherwise, in our case, what we have been doing is the time series data has been captured for 500 millisecond, because we are working on a stimuli, not a persistent car view or object view. If a car has been viewed for a longer time, I can get into la 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 land. Oh, I would own it. Oh, it had even Ferrari been nice, but Indian roads are bad, man. Oh, then I have to switch to the US. The prolonged view can trigger different thoughts in your mind. So that's why we worked on a stimuli basis. Immediately you saw something and something came in your mind. That's what we wanted to capture. All right, done. Thank you very much, guys.
Thank you so much, Rajesh. So this was the last talk for today. I would like to say, first of all, thanks to Prem for collaborating with us and all these speakers, Prashant, Manoj, Rajesh, and Kunal.
Sorry, very interesting.
Okay, so Cloudera have lot many open positions nowadays. So I have requested our talent acquisition team to be here, just give 2-3 minutes and share about the culture and open positions QR code. So I request Shreya, please to come talk over it. It will be beneficial for all of you. After this, we'll open for lunch.
Hi all, good afternoon. Just a minute, I'll have a slide up and we can just get started. Okay. Yeah, I'll just get started. So I'm not here to talk about Cloudera, technology, AI. I think we've had some great sessions already today. But and neither here I am to tell you that Cloudera is a pioneer in the enterprise data platform side, shaping how organizations are managing, analyzing, and activating their data. Rather, I'm here to actually give you a glimpse into something what we call Cloudera Life, which is basically our culture that we have built. And because of the kind of culture that we have and the kind of support we have given to our employees, we have recently been certified as a great place to work. So Cloudera's India offices have been certified as great place to work. So a lot of reasons for that. Some of them are mentioned here, and I'll just give a very quick overview about the same. We have something called the Global Unplugged Days. Now, we believe we believe in the concept of people first. So it's not just a saying for us. We genuinely believe in it because we believe that innovation can be sustainable only if the people who work with us are trusted, empowered, and supported. And there are a lot of ways that we're doing. One of them happens to be Global Unplugged Days, where we say work hard, but also have a good rest and recovery, regenerate yourself. So every 3 weeks, Cloudera has a long weekend for all the employees. It could be either a Monday off or a Friday off, or in fact, both Monday and Friday. So February happens to be a very lucky month for us because next week we have a Friday as well as a Monday off, a shorter month with even more holidays and shorter weeks to go ahead for us. Because we believe that if we don't rest and regenerate ourselves, I don't think we'll be able to, sort of bring in the kind of innovations that we have in our head on the table. Then we have a comprehensive work culture. So, with COVID, everybody went into a remote working, right? And we had a lot of industry best practices of flexible working. But as COVID, subsided, we're all coming back into return to work kind of an environment. However, that's not the case with Cloudera. There are opportunities that we offer with 100% remote flexibility, right? So, not just work from office or a hybrid model, but also 100% remote flexibility because why not? We don't want to limit talent only to Bangalore or only to our Chennai Innovations Hub, but why not giving an opportunity to allow you to work from where you are comfortable as long as you're doing the contributions that are needed. Then Zoom-free Fridays, I think that's something that we've been trying to follow very hard. And we have, of course, onboardings of new hires, not to rush them into the system, but to ensure that it is extremely seamless and they get an opportunity to understand the system, the organization, and everything else. When we talk about unplugged days and not having to work on certain weekdays, we just not believe in physical well-being, but also emotional and mental well-being. That's why we have a lot of employee assistant programs, wherein there are regular webinars, counseling sessions that you can, log into and attend that are there. Then we have career progression. Now, career progression as a word, some people say, okay, we don't get promotions, that, but Cloudera's managers, HR, and everyone else really believes in career pathing. We really believe in coaching and mentoring our employees employees for the next step and have a lot of opportunities for internal mobilities. We have subscriptions for Udemy, wherein Udemy self-learning courses, wherein you can actually go ahead and take courses, learn, and that is on us. Apart from that, if you feel that you want to do a course which is going to be beneficial for your career growth and hence Cloudera's career growth, there are educational reimbursement programs also that we have out here. Apart from that, of course, there are social bonding activities. We have festive celebrations, we have sports tournaments, and we also have fun meetups happening across. So, Cloudera, AI is being adopted everywhere, and Cloudera is also expanding its capabilities, not just on the AI front, but also core platform, our data service platform team, our Cloudera AI side. And we are actually helping organizations to manage their existing data and turn it into some real actionable insights. That is happening through Cloudera AI platform, our AI assistants, our AI studios, and each and every function that we're working with. There are a lot of open opportunities that are there, and I have two QR codes that are here. Yeah, there are two QR codes which will just be out here, which are basically for our India career page as well as for our LinkedIn page. So you can scan, you can see the openings which are there currently for the Bangalore office. And if I have to just give you a little bit of sneak peek, we are hiring for managers across our storage team, our CAI Cloudera AI team. We are hiring for multiple full stack developers having experience in Golang and React as a combination or Rust and React as a combination, a lot of staff engineers on the backend side, security engineers. So happy to discuss in detail about the openings, and please feel free to reach out to me or anybody else from the talent acquisition team. I'm the only one here right now, so happy to actually discuss about the openings, and let's see how you can start your Cloudera careers and Cloudera journeys. Thank you. Thank you so much.